Hi everybody. I thought I would do a short video on solving absolute value equations. This is something that we went over in class, but we took quite a bit of time to do that and we got into some pretty in-depth problems. So I like to just break it down a little more for everybody, just kind of make sure everybody has the basics. So absolute value equations. So absolute value equations will always have these bars here. That means take the absolute value of this number and it comes out to be 10. So absolute value is basically, one way to think about it is it just makes whatever's inside of these bars positive. If it was already positive, it doesn't do anything. And if it was negative, it just makes it the positive version of that number. So another way to think about it is with distance. So when somebody says the absolute, the absolute value of x is 10, they're saying that x, whatever it is 10 away from 0. If we just think about this on a number line, whoa, that wasn't that straight. So we have 0 here. And we could have two numbers that are 10 away from 0. And the first one everybody would think about would be just the number 10, regular old 10. The other number is, of course, negative 10. So one way to do this when we're solving equations, think about distance or thinking about making things positive, is if we get an equation like this, we're going to split it into two separate equations. One, we're going to write that expression without the absolute value symbols, just straight up. And the other way we're going to do it is we're going to split that expression into x equals, again, without the absolute value symbols, the opposite of the other side. And if we think about it, it makes sense. We know that whatever is in here, whatever's between these bars, needs to be positive. So if x was 10, that'd be great, right? So x is 10. That's easy. We solved this equation. It's already solved in this case. Or maybe x is negative 10. And that would actually be good too. If x was negative 10, the absolute value of negative 10 is 10. So the solution to the equation x equals negative 10 would also satisfy this. So I want you guys to think about this split occurring. And we want to get used to when we should be doing that split. Let's look at a different problem. So here we have an absolute value isolated on the side. And when I say isolated, I mean there's no stuff going on over here outside of the absolute value. Everything is contained within the absolute value. So what happens if 2x plus 12 was 18? Well, if this right here is 18, the absolute value of 18 is 18. So that would be good. This would be really good. Or if the thing inside of the absolute value, let's do it in a different color. If the thing inside of the absolute value was negative 18, that would also be good. So if this 2x plus 12, the expression inside of the absolute value bars, was negative 18, that would be good. So all we have to do now is we just have to solve both of these equations. Take away 12, we get 6. So we get 2x equals 6, so we get x equals 3 over here. And then over here we'll take away 12. Take away 12, that looks like a plus 2. It's all right, we know what it is. So we get 2x equals negative 30. Divide both sides by 2 and we get x equals negative 15. And let's see if this kind of works. We'll plug it back in just real quick. So let's put in this 3. 2 times 3 is 6, plus 12 is 18. The absolute value of 18 is 18. Let's try negative 15. 2 times negative 15 is negative 30. If we add 12 to negative 30, we get negative 18. So 2x plus 12 is now negative 18. Well, the absolute value of negative 18 is 18. So both of these are solutions to the equation. So often when you're doing absolute value, you're going to get either 2 solutions or 1 solution or 0 solutions. Let's look at a different problem. So here we have things going on outside of the absolute value. So we have this being multiplied by 2. We also have a 12 being added. So for reasons that we'll get into later, we always want to clear out stuff that's not inside the absolute value. So you're kind of treating this absolute value of x plus 2 as its own variable for now. So let's just clear everything away. We would first subtract 12, and we get 2 absolute value x plus 2 equals 12. And now, this is one of the main points I brought up on Friday, we cannot distribute this 2 just into this absolute value sign. So sometimes it's helpful to think of absolute value bars as a grouping symbol, but you can't just distribute into them. Sometimes you can, sometimes you can't. It's difficult to distinguish when you can and when you can't, so we're just not going to do it because there's really no need to. To clear out this 2, all we have to do is divide both sides by 2. And then we're left with the absolute value of x plus 2 equals 6. Now this looks like a doable problem. So here's where that split is occurring. And you want to do the split as soon as you get this absolute value isolated. There's nothing outside of the absolute value. So now either x plus 2 is 6, or maybe x plus 2 is negative 6. So we'll write it our 2 ways. X plus 2 just equals 6, just straight up, or x plus 2 equals negative 6. That could also be good. So either x is 4 over here, or x is negative 8. We could plug those back in and check that those are both going to be correct. Last one. Kind of a tricky one. Doesn't seem that different than the last problem, but let's just clear this stuff out. So we'll subtract 10 from both sides, and we get negative 2 times the absolute value of x plus 4 equals 2. And then we're just going to divide both sides by negative 2. And we get the absolute value of x plus 4 equals negative 1. So we know that we could just do the split here. We could just write x plus 4 equals negative 1. And we could write x plus 4 equals the opposite of negative 1, so maybe it just equals 1. Well, let's see what happens if we do that. We'll subtract, we get x equals negative 5 here. And you can get negative solutions. There's nothing wrong with that. And then here we get x equals negative 3. So, if I take these and I put them back into this equation, let's just see what happens. So, let's see here. Let's put this negative 5 in first. So negative 5 minus 4, that's negative 9. Negative 2 times negative 9 is 18. 18 plus 10 is 28. So this side is 28, even though I think we solved everything correctly. Let's try this number. -3. So -3 minus 4 is -7. Negative. Oh, I see what I did wrong. We have to put in the -5, and this is actually going to be positive. So let's try it again. So -5 minus 4 is -9. Absolute value of -9 is 9. So -2 times 9 is -18. -18 plus 10 is -8. So -8 equals 12? It does not. So this is nonsense. Let's try it with -3. -3 minus 4 is -7. Absolute value of -7 is 7. -2 times 7 is -14. -14 plus 10 is -4. So now this whole side equals -4, but that side equals 12. And we did everything correct, but we got some extra solutions. So in math, these are called extraneous solutions. It means they're extra solutions that when you check them back, they don't work. And here's a couple different places that we should have been able to realize that this wasn't going to work. Here's the first one, right here. At this step, the absolute value of anything is positive. Yet here it says it equals a negative number. So this right here, if we just break it down in terms of what their symbol should be, that's just this whole chunk here, including the absolute values, is a positive, and then this right here is just a negative number. So this is saying a positive number equals a negative number, which is never true. Here is the other place we could realize that. This is saying a negative, this here is just a negative number. This here is a positive number. And over here we have a positive number. So this is saying a negative times a positive, because that's what this operation here is, right? A negative times a positive is a positive. Well, we also know that that's never true. So we need to be on the lookout for these types of situations. You either need to realize it here, once you get rid of this plus 10, and you have this by itself, and it's just a number times the absolute value. Or you need to recognize it here when the absolute value is by itself. So that's your guys' options. You can either recognize it at one of these two situations, or you could do everything normally and pretend everything is fine until you get your solutions. But if you do that, you have to put them back in and check to see if they are extraneous or extra solutions. So two options for you guys. Look at it this way, or do it the normal way and see if you have extra solutions. But don't get too carried away with this, because most absolute value problems are simple ones like we just did. These are more of the exception to just be on the lookout for. Have a great day.